Hi everybody. So in this video, we're going to look at the complex roots of a quadratic equation. So if we have a general quadratic that's been factorized and it has roots at, let's say, alpha and beta, then the factorized version of a quadratic could be x minus alpha multiplied by x minus beta, and this will equal 0. And if alpha or beta is a complex number, let's say alpha is going to be a plus bi, then beta, the other root, will be the complex conjugate of alpha, so a minus bi. And together, these form what's called a complex conjugate pair. So if we go back to our quadratic and we can expand this out, well then we'll have x times x, which will give us x squared. We'll have x times minus beta, so negative beta x. Negative alpha times x, so negative alpha x, and then negative alpha times negative beta, so plus alpha beta, and this will equal 0. Now we can factor out the negative x term. So what we're left with is x squared minus alpha plus beta multiplied by x plus alpha beta, and this will equal 0. So the reason why we write it in this form is because if we know alpha or beta, then we can easily recreate the general quadratic using this formula. And in example 1, I'm going to show you how this works. Okay, so in example 1, use the equation x squared minus 6x plus 25 equals 0 to show that the solutions form a complex conjugate pair. So I'm going to solve this quadratic by completing the square. So we'll halve this value, negative 6, and we get x minus 3, all squared. We'll complete the square by taking away the 9, then we'll add back in the 25. This will become x minus 3, all squared, plus 16. Then we can move the positive 16 to the other side, so we get x minus 3, all squared, will equal negative 16. Now we'll take the square root of both sides, so x minus 3 will be plus or minus the square root of negative 16. And if you remember from a previous video, I showed you that we can write the square root of a negative, in this case negative 16, as the square root of 16 multiplied by the square root of negative 1. And this root negative 1 we call I. So this becomes x is equal, move a negative 3 to the other side, so 3 plus or minus the square root of 16, so 4, and then I. And you can see that alpha would be 3 plus 4i, and beta would be 3 minus 4i. And together, they form the complex conjugate pair. And then for part B, we've been asked to factorize this quadratic equaling 0. So now we can use what we've created over here. We'll have x minus alpha, so minus 3 plus 4i. We'll put all of this in brackets, multiplied by x minus beta, 3 minus 4i. Again, we'll use brackets, and that will equal 0. Okay? So this is how you can factorize a quadratic using its complex roots. And in example 2, we're going to look more at how we use this part of a formula. Okay, so in example 2, the roots of the quadratic equation z squared minus 2z plus 26 equals 0 are alpha and beta. Find alpha and beta. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you're ready to go. So to solve this quadratic, we need to complete the square. We could use a formula, but I'm going to complete the square. So we'll get z minus 1 all squared. We'll minus the 1, and then we'll plus the 26, and this will equal 0. Then we'll move this to the right-hand side. So z minus 1 will equal negative 25. And then we'll take the square root. So z minus 1 will equal the plus or minus the square root of root negative 25. So plus or minus 5i. Then we can add 1 to both sides. So z will equal 1 plus or minus 5i. Okay? So we can see that alpha would be a positive case, 1 plus 5i. And beta would be the negative case, 1 minus 5i. And if we go back to this relationship here, well, we can work out alpha plus beta, which will be the number before the x term, which is in this case negative 2. So alpha plus beta will be equal to 2. And I want to show you why this works again. So if we add alpha and beta together, so for part B, alpha plus beta, this will be 1 plus 5i alpha plus beta, 1 minus 5i. This negative 5 will cancel with this positive 5, and we're left with the 1 and the 1 to make 2. And then for part C, alpha beta, well, we know this will be our constant term, which is 26. But if we multiply them together, so alpha multiplied by beta, 1 plus 5i, multiplied by 1 minus 5i, well, 1 times a 1 will give us 1. The negative 5i will cancel with the positive 5i, and then we get negative 25i squared. But we know I is root negative 1, so I squared will be negative 1. So this will be 1 minus negative 25, which becomes 1 plus 25, which is 26, which is exactly what we thought it would be here. Okay? And in example 3, we're going to look at forming the quadratic when we know one of its complex roots. Okay, so for example 3, we're given that 2 minus 3i is one of the roots of a quadratic equation with real coefficients. For part A, we've been asked to write down the other root of the equation, and then for part B, we've been asked to find the quadratic in this form where B and C are real constants. So do you want to try this question yourself? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So we're given that 2 minus 3i is a root, so we can call this alpha. We know alpha and beta form a complex conjugate pair, so beta will be 2 plus 3i. And then for part B, we can go back to using this relationship, where the negative coefficient of x will be alpha plus beta. So we'll have alpha plus beta will be 2 plus 3i plus 2 minus 3i. These two will cancel. So alpha plus beta will be equal to 4. And then for our constant, we can just work out alpha beta. So 2 minus 3i multiplied by 2 plus 3i. We can expand this out, so we get 4. The plus 6i will cancel with a negative 6i. And then we get negative 3i multiplied by 3i to give us 4 minus 9i squared. This I squared will be negative 1, so 4 plus 9 will be 13. So finally, our quadratic will be x squared, alpha plus beta, so minus 4, x, alpha beta, plus 13. And this will equal 0. Okay? Well, thank you very much for watching, and I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.